All right, so I think we're, oh, there we go here. Not quite there. There we go, share screen now. Okay, now we're there. All right, so let me talk for a minute. Whoops. Get this on. Homework problem 2. Hopefully you got the email. And I apologize, but like I was telling a couple students here, great learning opportunity. But yeah, I really stepped into problem number 2. I didn't really think it through, slapped it together. And when we found the first problem on Wednesday, I figured, oh, that's good. But as noted, if I know the hydraulic grade line out here at the middle being 170, and so I'm going to do the hydraulic grade line coming down from 1 and 2. It's not drawn to scale, obviously, because this one is 258, and this is 232, and this one down here we don't know, but we know that that's 170. So we know the flow has to come this direction. We know the flow has to come this direction. And I said there was flow of 1.2 in the third one. Well, a lot of you found out that when you did the energy equation from A to the junction and from B to the junction, and then you looked at this flow right there, there was no way to balance out continuity. And that is a physically impossible problem given the current parameters that we have. If we had other parameters, such as flow is being drawn off somewhere else, then that would fit. And so when I redid this and gave you the hydraulic grade line of the junction, I should have done away with that. And then it would have been a solvable problem because why? Because you could calculate the inflow from A, the inflow at B, and you know exactly then what is the flow going down to C, because both of those are coming in, A and B are coming in. So you know it has to go to C. So now that I know that, I can calculate the head loss for that known flow rate and start the hydraulic grade line and then calculate the hydraulic grade line at C. And that was the intent of the problem. Just spaced it off. And then from there, once you find all 3 flows, you can find then the pressure in PSI at the junction, because I also, here's the elevation, which I posted kind of late as well, right? So this has kind of been like a bad nightmare for me. I just kind of want to forget it. But that was the intent, to show you that not all 3 reservoir problems require you to iterate. Some 3 reservoir problems just fall right out, all right? But still, it's a good concept. It's a real world problem for understanding the concept of hydraulic grade lines. What if I give you a 3 reservoir problem like this? So this is the symbol for a pump. And let's say that this was 100 and this is 70, and my pump provided a pressure. The pressure at the pump was equal to 60 psi. And what I'm trying to highlight here is something that I've told you multiple times as well, is that reservoirs just represent energy at the location that it's at. So that pump is adding energy to my system, right? Obviously there's flow coming in somewhere to that pump, and then that pumps work in one direction, at least that's what they're supposed to do. So I definitely know that flow, if I call this 1, 2, and 3, and I definitely know that flow is going from 1. Okay. I don't know if there's something I'm accidentally hitting down here. I don't think so. Okay, we'll shut this down and get started. Does that light help any? Okay.
No, it's shining as well.
How's that? A little better? So, no light with light. Doesn't matter? Yeah. All right. We'll see what it does there. Okay, so reservoir, pumping water along pipe 1. 2 and 3, we don't know exactly what's going on, but once again, we know that this is the lowest. Okay, so we're definitely going to have flow going this way. Is it possible for the flow in pipe 2 to come down and join up with the pump and go down to 3? Sure, it is. Or it could be possible that that pump is supplying both reservoirs, all right? But the concept here is we just figure out what the hydraulic grade line of that pump is, because we know the hydraulic grade line is equal to P over gamma plus Z. So if we know the elevation of the pump, we know the pressure, now we can calculate the hydraulic grade line. You can just take that pump off of there, throw up a reservoir if you wanted to. There's no need to, but if if that visualization helped you, then you're back to a 3 reservoir problem, right? So we can connect to a water system that has a known pressure. We can hook up to a pump. We can hook up to a reservoir. Once again, the reservoir is just representative of what's going on in our system. Okay. Now, with that, I didn't bring any other paper with me, but because I wanted to show you something on the computer. So I have downloaded this to Moodle, and you don't necessarily have to get it and follow along, but if you're like, oh, I want to work this one too, see how it goes, that's fine. So I have a 3 reservoir problem here. The hydraulic grade line at A is 100 meters, the one at B is 70 meters, at C is 30 meters, the elevation of the junction is 50 meters, okay? And I want to calculate what is the flow in my system. And I want to do it numerically so I don't have to sit and iterate by hand, because today we use computer programs, right? But we still need to know, but by the way, I don't know if I've shared this, guys, with you. You know what the difference in between an engineer and a technician is? It's about 30,000. No, no, here's the reality. A lot of the stuff we do as civil engineers, we sit down on a computer and we let the computer be our tool, right? Could a technician do that? Sure, they could. And they do it for a whole lot less cheap. By the way, there's some very good technicians out there. And sometimes it's really good to listen to what they have to say, because their years of experience is worth something. But what's supposed to set you apart as an engineer is you understand the engine. You understand what's going on with the numbers behind the scene. You understand the assumptions that are made to make that computer program work. And if you violate the assumptions, that you're going to get garbage out, or you have to be really careful about the answer. So there's a reason why we show you all this stuff, so you kind of have an idea how the mechanics of these problems work, and you understand then these are the parts going in, and you have a better idea of what's coming out, all right? So it's not just because, hey, I want you to learn this, it's because it's important to understand this concept. Okay, so we want to be able to solve this somehow numerically, and remember, we came up with energy equations going from across the whole system rather than just to the junction. For example, for this particular problem, if I know that A is 100, B is 70, and C is 30, I know flow is coming from A and going towards C. I don't know what's going on at B, right? So I could write very simply the equations. The hydraulic grade line at A minus C sub 1 times Q sub 1 squared plus or minus C sub 2 times Q sub 2 squared is equal to the hydraulic grade line at B. I can also write then a hydraulic grade line at A minus C sub 1 times Q sub 1 squared minus C sub 3 times Q sub 3 squared is equal to the hydraulic grade line at C. So we worked these before in the class. And then our third equation is that Q sub 1 plus or minus Q sub 2 minus Q sub 3 equals 0, our continuity equation. right? We had those equations and we said we're now going to linearize those equations by using this concept of Q old and Q new. Q new is what we're solving for. Q old is known. And by knowing Q old, we can linearize the equation, and then we'll just sit and iterate and update Q old to find the answer. Okay? All right, so given that then, I'm going to come back over here, and here's all the information for the system. We have 3 pipes. There's the friction factor, the length, the diameter, and I want to calculate the C value. The first thing I'm going to do is I'm going to take that diameter and turn it into the base dimension of meters. So I'm going to divide millimeters by 1,000. Okay, and these are standard nominal millimeter sizes in the metric system. Those are, that would be equivalent to like a 6-inch pipe, 8-inch pipe, and so forth. All right, then I know that the area is pi divided by 4 times d squared. So I'm going to use the one that's in terms of meters. Okay, copy that down. And then my C values, I said was F times L over D. So if I want to kind of put it in that form, so L divided by D, once again using the meters, so that's dimensionless, times then 1. And I could simplify this equation, just trying to put it in this form to remind you, 1 over 2 times G, so 9.81, times the area squared. Okay, and there's my C value right there. I'm going to clean that up a little bit. Don't need quite that precision. Bring it down here. All right, those are my C values. All right. Now, yes. Well, that's what I'm going to talk about next here. Okay. Now I'm going to come down and I'm going to make some guesses. Now, if I assume that the flow is coming from 1, going 2, 3, and also coming from 2, this does not meet continuity, not by any stretch of the imagination. But that's the beautiful thing about this concept, is we don't have to meet continuity, and it will go to continuity. All right. So I threw Q equals 1 in there just for fun. I could start off with Q of 0.5, 0.5, and 1 there if I wanted to, or 1, 1.5. I don't care. I would not recommend you start with 0 though, because that now kills a lot of your coefficient matrix, and you get the, what they say in linear algebra, you get the null of the matrix, right? Or the kernel, whatever. I can't remember all those terms, but so those are just my guesses. Now I'm going to come down and build my matrix A. Okay. Now I'm going to have to make an assumption. I'm going to say that Q, so 2, is 2B, is going to B. All right. It's just like I took in statics. I have to put a force on my reaction forces. I have to assume a direction, so I'm going to assume it's going to be. So when I come down here to matrix A, the first thing I'm going to do, should have taken these out there. Okay, so now I'm going to put in my continuity equation. So my continuity equation tells me that A is at the junction, A is going in, or 1's going in, so it's positive. B is going out, so it's a -1, and C is going out, that's a -1, right? So that if I jump back over to the overhead, that's my Q equation, my continuity equation. And the B vector then is going to be 0, right? Yeah, so we can write the equation out here to the side actually. Q sub 1 minus Q sub 2 minus Q sub 3 equals 0. Yeah, so that's the continuity equation. And by assuming the direction to B, I know that Q sub 2 is negative. At least I'm assuming that it is. Okay, and then I'm going to come down here to matrix A, and now I'm going to put in the coefficients. Well, the coefficient of my first equation, remember the equation then, hydraulic grade line at 1. Now, I'm going to reorder this equation because the hydraulic grade line is known, right? So I'm going to write it as minus C1 times Q1 can I use a prime here? Times Q1. And then I know that I'm going 2B, so it's going to be positive because I'm going up the hydraulic grade line. So Q or C sub 2 times Q1 prime, and Q1 prime represents Q old, right? Times then Q, whoops, that should be Q. Come on. Q, and I'm going to have to put, this is a label, not an equation. Okay. C sub 2, Q sub 2, there we go, Q sub 2. And all this then equals the hydraulic grade line of B minus the hydraulic grade line of A, because I took A over the other side, right? So when I do this equation now, remember I'm solving for Q sub 1 and Q sub 2. So my known values are the C values and the Q prime. So I'm going to come over here. I'm going to go, and first off, I'm going to come up here and label these guys. So if you remember from the civil tools class, I can label these. So I'm going to call that C1, although I think C1 is, I can't use C1 because these are addresses. So I'm going to actually call this C1 dot. It's not going to let me do that. I thought it would let me do that. All right, it's okay. We'll do it the other way. C dot 1. There we go. This up here, C dot 2. And this one here, C dot 3. All right, so I've just labeled those so I don't use absolute values all the time. Remember, relative values, absolute values, because those don't change right now, because I'm assuming I know my friction factor. So now I come down here to my matrix, and I'm going to go minus C1 times then Q1 prime or Q1 old, which is my guess up here, right? And then it's going to be plus C2 times my old value of Q2. Whoops, and I'm getting ahead of myself. That goes in the second one over here, right? Now I'm also getting ahead of myself. Did I tell you that since I know the direction, this is absolutely not needed here, but it is good practice to put in the absolute value because this is what we'll be doing when we do pipe networks, because we don't know the direction in pipe networks. So, and it's not going to hurt it because the absolute value maintains the direction. It's not going to hurt it. So here I'm going to do then plus C2 times the absolute value of Q sub 2. Laura?
So how come is the C2 positive now?
Okay, so the C2 is positive because I assumed that Q2 is going to be, so up here, the direction of this is going this way.
So that'd be like against,
So I'm, oh, you're right. Oh, I did that wrong, didn't I? Thank you. Because I'm going 2B, so I'm going with the flow, so it should be negative. So you're absolutely correct. So this should be a negative value. Thank you. Because if I'm going with the flow, I'm going down the hydraulic grade line. So over here on my equation, that should be a negative value. Okay, make a little more sense? Okay, thanks for catching that. All right, and then there is nothing for Q sub 3, so that's 0. And in my B vector, I'm going to get the hydraulic grade line at B, here I'll make that absolute value, minus the hydraulic grade line at A, absolute value. I'll go on that with F4, so that's negative 30. Okay. Oh, and that's, go ahead.
So the difference in the HLB minus HLA, that's what the B vector represents?
The B vector represents the values that are not tied to my variables. So if I have a vector system, 2x plus 2y equals 5. 5 is the B vector because it's not tied to the variables. Okay? All right. So now I can come down and do the next one. Well, the next one is going to be essentially the same thing, except for now I'm going down C sub 3. So it's going to be a negative C sub 3, Q sub 3 prime times Q sub 3 prime, and over here it's Q, or HGLC minus HGLA. Okay, sure.
It's like, for those, for the matrix A, it's like, you get like negative Q1 prime, absolute value Q, right? Or,
Right, so when I put that into the matrix, then I'm going to use absolute value on the Q primes, on the Q olds, to make sure that I maintain direction, because otherwise if I square it,
absolute value, the Q prime or the regular Q?
the Q prime, and Q prime represents Q old. So up here we can say that Q
Oh,
prime, whoops, that was a label, Q prime equals
Q old?
Q old, yes.
And that's the one you put an absolute value?
Yes.
The regular Q?
Yep.
Oh, and what's the concept behind it? It seems like it's all following the same pattern, negative C, Q prime, absolute value, and then regular Q. So what's the principle behind that? Why is it like that?
Well, if I take a negative number and square it, what happens to it?
Positive,
It goes positive. So if my numerical method tells me that the flow needs to be negative, but every time I stick it in the matrix, it squares it, it's never going to go negative.
So is it even necessary to make it absolute?
Yes, because that maintains the direction.
Oh,
Because Q times Q, if they're both negative, it becomes positive. But if I take the absolute value of 1, then I get always a positive times a negative. So it maintains the direction.
oh,
Okay? All right, so when I come over here, I'm going to get the same value right there, correct? Except for, you got to make sure that that stays with Q1. Okay? And then I have no Q2 in there, and then for Q3, I have minus C sub 3 times Q sub 3 here. Absolute value, Q sub 3. All right, and then here I have HGL at C, so HGL at C, and make that fixed, minus the HGL at A, and make that fixed. Okay.
Are those guesses that you're putting into the matrix, are those the Q olds or the Q names?
These are Q olds. Because now that I've guessed them, they are known, and so they become old.
so we're solving for Q new, right?
We're solving for Q new, yes. Okay. So now if I'm solving my matrix, I know what I do. Yes, exactly. We got to be careful about it, right? If we have the coefficient matrix A times then the solution vector X is equal to the V vector, okay? We have to multiply this by the inverse, and that just goes to the identity matrix. And then we got to make sure when we do it over here, we do not do it over here. That's bad. You got to go to the inverse of A times B. Remember, you just can't switch them when you're doing vector math, right? So inside of the spreadsheet, we go matrix multiplication, M mult, times the first thing is M inverse of this matrix right here. And we're going to multiply that by the B vector. Okay, so M multiply, what are we multiplying? The inverse times the B vector. Okay, and when I go ahead and hit enter, that's going to fill that in, but it's not going to fill in the other 3, and I know my solution should have 3 there. Okay, so remember the sequence here. I'm going to highlight this right here, drag it down, hit F2, which is edit, and now I'm going to push at the same time, Control Shift Enter. And there's my answers. Sure, I'd be happy to. So let me go back here. When I type this in, I type matrix multiplication, M mult. Okay, and if I came over here and went M mult, just to show you here, okay, this down here, if I move my mouse down, or it should tell me, right? Mult. Okay, there we go. It tells me that it's array 1 times array 2. Well, I want my first array be A inverse. So that's why when I come back over here, I do M inverse of my A matrix. And then my second array is my B vector. So when I get all that done right there,
So the first, the array one, array A is what again?
array A is my inverse.
Is that, then what is that? And just,
It's this matrix over here. This is my A matrix right here
okay,
that I have highlighted.
that's the A inverse?
That's A.
That's A. But
So I have to take the inverse of it.
A inverse, right?
So I have to take the inverse by taking M inverse.
So that whole thing is A inverse?
Yes. Now you go back and look at your linear algebra. An inverse matrix C has the same size, just flipped. I guess you could say rows become columns, columns
So
become
array
rows.
one would be the A inverse, right?
Yes.
Okay.
Okay. Now that I have that, I can come down here. Once again, the key sequence is Control Shift Enter, those three keys at the same time. Whoop, F2, yeah. I'm going to turn it into edit mode. Control Shift Enter. So Control plus Shift plus Enter. Okay.
So after you put, what is that again? Where do you press control shift and
To solve the matrix C.
after you do what?
After I've got the equation in there,
M all, right? And you put array one, which is A inverse, what's array two, B vector?
B, yes.
Okay, and then after that, you press control shift enter and you'll put the other two values?
Yep. Okay. So now that I have that, this is now my new guess. And I can now then use that. Q new becomes Q old. All right. So I'm going to go ahead and copy this down. And I'm going to leave two spaces, just whoops, I want two spaces just for fun. So I grab that, bring that down. You'll note that it now, I guess if I would have went three spaces, maybe let's do that. So this is a good example of relative. You know, if I know that here's where my old guesses are and my new guesses are 1, 2, 3 down, if I just come down three spaces and paste that, now I'll note that my flow rate in that first box, C1 times Q, grab the new value, which becomes the old value. Q new becomes Q old. Okay?
Do what?
Q new becomes Q old.
Okay.
Okay? So all of those now are ready to go. It's my new
So
value.
you could, for that matrix, the new one you just did, so you just replace all the Q old with the Q new,
Yep.
the same equation?
Yep, exact same, just updated my Q value.
Okay.
That's my new guess. My Q values are my new guess. Okay, so now I can bring my B vector down as well, and also my solution down, copy those down.
Will those change too?
Sure they'll change because now they're using the updated A matrix. Now the B vector won't change,
Okay.
but now it changes my answers and I can see that one of my values went negative.
I have a question.
Okay,
Could you just take the Q new, copy those three as values, not as equation components, and just paste them back up into Q old guess and have it iterate again without having to rebuild another table?
yes, you could. I'm going to show you a way of doing that here pretty quick.
Okay.
It's a really powerful tool inside of Excel for certain situations like that, okay? So now, now that I have that, I know that as long as I follow the same pattern of skipping three, the relative values are always going to go grab my Q news and make them the Q olds, right? So now I just grab that and just drag this baby down. Boom, there we go, okay? Now I want you to know.
Yes, that's like you did a lot of iterations.
Yep, I just did a lot of iterations right there, okay? Now you'll notice that, and I probably shouldn't have had three spaces because it spreads it out a little bit, but you'll notice that it's kind of interesting that there seems to be a pattern here, okay? No, there doesn't seem to be a pattern. Maybe down farther here, I'll get a pattern. Okay, so 1.5 essentially for Q1, and then we go to 0.03, and then 1.3, and then 0.03, and so we're kind of bouncing around between these two values, 1.13, and we're going, yeah, Okay, and they say, what's going on here? Well, without getting too much in the mechanics of numerics,
You need another piece of paper?
if you got one handy, that would be wonderful. I apologize for not being there prepared. Didn't think that, I thought this one would be enough. Thank you. Ooh, that's, oh, there's a couple there. Thank you. Essentially what we're doing with a numerical method, imagine if you will, and the equations are x squared, so they're parabolic, circular, parabolic, whatever you want to call it, right? So imagine if you will, if I had my solution was something like this. Okay? And numerically, I'm coming in, well, let me take a step back. Let's say that I'm going to come over here and draw another graph. Let's say that I had a curve. And I knew this point right here. So this represents some x1. And I can find the slope, m. So m is the slope. So if I know the slope, I can kind of project the slope up. And for some delta x in here, so x1 is correlated to a y1. And for some delta x in here, I can then predict what my new y sub 2 will be, right? Because I know that y sub 2 is equal to m times delta x plus y sub 1. It's a little equation of a line, right? So, I mean, this distance right here essentially becomes then delta y. So I'm going to take y sub 1, add delta y in there, and I'm going to get y sub 2. That's a numerical method. Now, it's not exactly on my line, so what this is right here, this right here is what we call error. Okay. But that's the concept. Oh, sorry. There. That's the concept of how numerical methods work, is they take a derivative of some sort, predict where the next answer really should be, and then say, okay, here it is, and then we have to figure out what is the error, and do we need to fix it again? Well, in this case, because the system is nonlinear, in essence, what we have is we are taking the derivative right here, and it is shooting clear over here, and then we come up here and we say, okay, here we are right there, and now we take the derivative over here, and guess what? It shoots kind of right back in the same spot. So it just keeps oscillating, right? Which is not uncommon for something that has a high curvature for it to oscillate. So we just have to find a way to better handle that. Mark? Yep, that's the same thing that's going on inside our system right now. Okay? And there's an easy fix to it. What we're going to do is we're going to take a smaller step, or we're going to take the average of those two oscillations, if you will. You take the average of those two oscillations, now you move in between them, and you actually get closer. The answer is at the bottom, and when you take the average, you get closer and closer to it, right? So what I'm going to do is I'm going to come up here, and I'm going to take then the average of my last two values. So however you want to do this, you can either calculate it manually, you know, a plus b divided by 2, or I can use the command inside of Excel of average. I'm going to take the average then of this number and this number. And if I copy that down, now I have the average. I probably ought to clean these numbers up a little bit.
What did you do there? So you took the average at the top.
I took the average of the last two Q values. I could have just as easily have taken the average of the Q new and my initial guesses over here. If I move those equations, I could do it up there too. There's nothing wrong with taking the average using my initial guess. But the concept is I'm going to take the average to take a smaller step, if you will. I'm not going to go clear over here. The average then says slow the step down. Don't take such a big step. And let's see if we can find where the minimum is at, because the minimum is the solution to this problem.
Dr. Lewis, you took the average of 0.027 blah, blah, blah.
Yeah, so watch this, Mark. When I put F2, edit, it shows me the two that I'm taking the average of.
Could you have also taken those in the middle of the average of the middle?
Well, I did. Down here, I took the average of those.
Oh, you did the whole thing?
Yeah, I took the average of all those.
Oh, the whole cell? The whole-
I took the average of all my answers, all my Q values. I took the average of those.
Oh.
Okay? So now I'm going to come over here into my next matrix, coefficient matrix, and rather than use the Q old or the Q new that I found, I'm going to use the average value. Okay? So I will use then, I'm just going to move all these over to the average value.
What were you doing there?
Rather than using my new Q, I'm going to use the average Q now.
You're plugging the average to the third matrix?
Yep,
Oh,
plugging the average Q into the coefficient matrix. Okay? And now when I do that, if I copy down my new updated A matrix, coefficient matrix that is referencing the Q values, I guess I should copy those down as well. So in fact, let's just grab this whole, gotta be careful what I do here. Grab this one down here and bring it down there. Okay, so now this one becomes the average between those two. Okay, so now I can grab these guys right here. I can grab this whole thing, including my spaces, and I can drag it down. All right, I'll take it down as far as I did the other one. Okay, and you'll notice that those now have fallen right in line with each other. In fact, they fell in line pretty much to the third decimal way back up here. Okay.
so when you iterated it, you just did the same process when you
Yep.
place the average Q into the coefficient matrix and iterate it all?
Right, iterated everything down.
They're all kind of the same, 0.19.
Yep, so they have converged. When I compare those two now, that is close enough, really. They've converged.
And that's what you want instead of like 1.3.
Right. When our Q new and our Q old approximate the same value, we have the answer. And notice that in this particular problem, I had two of the flows incorrect, which kind of makes me a little worried about if I've done something wrong here. I think I've screwed something up here. I must have a minus sign or something wrong. Oh.
That somehow is not -1, that's the top.
No, yeah, well, this is where Excel thinks it's smarter than me.
Oh, it looked at it as a series.
Yeah, it added those as a series, and these are supposed to be zeros. So let me show you on that how we fix that. And so this is correct there, that's correct. This should be 1 as well. Okay, when you copy things down inside Excel,
-1.
a -1, thank you. Yeah, when I copy things down inside Excel, it looks for patterns and it says, I found a pattern here, and so I'm going to increment those. So you can see that these values start to increment, and that's not what we want. So when I copy this down, Excel didn't used to be this way, but when I copy those down, I get this little box down here, and rather than fill series, I want to copy cells. So when I come down and check my coefficient matrix, I should note that the coefficient matrix down here at the end has zeros in the appropriate places, and my continuity equation does not change because it's already linear. Okay, Mark?
So what was the mistake? Like you just filled the series?
Excel automatically, this little box right here, that's the autofill option,
Yeah.
and it automatically assumes fill series. You don't want that, you want copy cells.
And it just, if you copy the cell, change that, will it fix it?
Yep.
Oh.
Do you always have to do the Q average or only when it has like the all?
It's good practice to do Q average, because if you set this up and then you grab your spreadsheet from, oh, I'm going to solve this next problem, and it starts to some systems don't oscillate as much, but it's good practice to have that in there. Okay. Laura?
Do you compare, because you're comparing if Q old is the same, roughly the same as Q new,
Mhm.
you compare to the previous box or to the previous average one? Because you're putting in the average into the matrix.
So it doesn't really matter, because once those start to come together, they start to mimic each other and the average. Depends on what your error tolerance is.
Okay.
I would say that, you know, if I took and converted these over to 3 decimal places, you would see that without the 3 decimal places, they are all the same. So I have converged and they're good. Okay. Other questions? Okay, now Scott pointed out, wouldn't it be nice if we just take our values and stick them back up? And rather than doing all this, although, you know, it's drag and drop, so to speak, or drag down. So it's not too terrible difficult, but in programming, if we're writing a computer programming, I'm just going to copy this over here. Okay, and I'm going to call this one circular. But in programming, we do this by loops. That's how we do iterations. We just sit and iterate, right? Sit and do the loop until our error, the difference between our expected value and our other value, is small, and then we kick it out of the loop and go do the next thing. So I'm going to come back up here, and I'm going to try and make this a little bit more like computer programming. Let me clean up the spreadsheet here. Let's see the border there. Okay. All right. And I could actually simplify this down. Well, let's take it down to the bare minimum. Delete those guys as well. Okay. These out here, and over here I'm going to do Q average. So now I'm going to take the average value of my Q new and my Q old, and that's going to give me my average value there. Okay. Oops, didn't get all 3 of them there. Kind of clean it up here a little bit, make my life a little easier. Now, if I can take these Q averages up here, then this should be nice, right? So I'm going to go ahead and take that one back up there. You've got a circular reference, all right? Which is what I expect. I'm trying to do a loop. So I'm going to go ahead and click on OK. And then I'm going to do the same thing down here, but let's see, I think that before I do that, let me go in and say, all right, I know it's a circular reference, so I'm going to tell Excel circular references are okay. So File, Options. Okay, and I'll post this video. I'll put today's lecture up so you can see it today. All right. So then I come into formulas. So let me go through that again. I lost my train of thought here. So File, Options, Formulas, and over here on Formulas, the right-hand side, it says Enable Iterative Calculations. Now there's a little bit of error checking here because iterative calculations can put you in an infinite loop. The spreadsheet would just sit there and calculate. So it says iterate at least 100 times or to where the maximum change is 0.001. And I can change those. I can make those greater. I can make the maximum change smaller. That right there is good enough for me right now. So I'm going to go ahead and click on OK. All right. So now in my, what's that? Yep. Or if you want to be more precise. So now I'm going to come over here and say Q1 old becomes the Q average value. Okay, and the next one in Q sub 2 becomes the average of Q sub 2, and Q sub 3 becomes the average of Q sub 3. Okay, and voila, look at that. If I come back over here to my matrix values, and I'm going to grab those values over here and bring it over here and paste them as values, and then clean them up a little bit, you can see that it works. So if we were programming this, writing a program to do this, we would just do a loop. And that's all we're doing. Okay. You know, if I ran the circus, I'd have you guys take a programming class other than the CS 1181, where you could actually do like Fortran. And then you'd be able to do this in Fortran, which is kind of instructive actually. You're like, yeah, maybe CS 1181 wasn't so bad, huh? but we just don't have the number of credits anymore to add that kind of stuff. So we do it inside Excel, which everyone has Excel. You're going to be, well, maybe you won't be amazed, but you use Excel a lot when you're out practicing as an engineer. Excel and, you know, word processing. Okay. Yep, it's just, it moved so fast you didn't see it. If I push, watch down here in the left-hand corner, it says calculate. If I push F9 and it tells me that, click here to press F9 manually to calculate, it will sit and look like it's updating. Okay? That is correct, yes. Okay. If I came back here into options and I said formulas, do this once, came back over here and started off with my initial values, right? And they do the same thing now. So I'm going to come grab a Q average. I'm going to grab of all those. I guess I could just drag that down, but anyway. Okay, so you'll note that this is not the same value now because I only let it iterate once. So if I hit F9 now, it sits and iterates one at a time. And you'll see that it starts approaching that other value, and I'm just about there, getting closer. Boom, now I'm there. Okay, so that's what I did right there. Just copy down every time I iterate, and if I just let it iterate 100 times, it's done.
And how many times do you want it to iterate?
Till it converges to whatever value you say is within your comfort range.
So, then the higher the number, the more precise it is, like we do 1,000 iterations.
Yeah, the higher the number of iterations, or the smaller the error value between your average value and your old guess, then that's your error value. Okay. All right, we're out of time. So your homework problem, I'm going to give you two homework problems. One's going to be due by hand. I'm out of the book, and the other one's going to be doing this with the problem. The homework problem that we had on this one here, where you had to solve for the three flows. Problem number one, I want you to solve that numerically using this spreadsheet with using both the matrix method copied down and the circular method. And I'll post my lecture today on Moodle, so you'll have access to that. Okay.
Do you want us to upload anything on Excel?
Yeah, when you get done, I want you to upload it, but don't upload it on, well, technically it's due Tuesday anyway, right? But don't upload it because on Monday, we're going to talk about another method of solving these systems. And this is all instructive to help you when we go into pipe networks, that you'll be able to solve pipe networks relatively easily. Okay, so Monday, I'll add part 2 to the homework assignment. So everything will be due on Wednesday. No, because Monday you'll get part 2 of the assignment, and it will all be due on Wednesday. Yes, that would be part 2. Bye, guys. Enjoy your weekend.
Yeah, Dr. Lewis, I'm sorry to ask too many questions, but I just want to figure out how to do it, you know? I'm sorry, it's almost like everything you say, I would ask the question, I just want to get it, you know?
Right.
Yeah. Well, so you said, so the first part would be like doing an Excel, right?